Welcome to the Explainer. Today, we're going to peel back the layers on JavaScript to really see what's happening under the hood when you run your code.
It kind of feels like magic, doesn't it? You write some code, you hit run, and stuff just happens. But it's not magic at all. There's a super logical, almost beautiful process happening behind the scenes, and we're going to break it all down.
All right, let's dive in. Here's our game plan. We're going to start with the absolute foundation, this thing called the execution context, and then we'll build our way all the way up to the Callstack, which is what manages the whole show. I promise by the end of this, you're going to see your code in a totally new way. So first things first, literally everything, and I mean everything that happens in JavaScript happens inside of something called an execution context. It's the environment, the little world where your code actually comes to life.
Okay, so what is it really? Well, the simplest way to think about it is as a special container that the JavaScript engine builds just to handle your code. And this container, it has two main parts inside.
The second you start running any JavaScript file, the engine creates what's known as the global execution context. Think of it as the main stage for your entire program. And it's split into those two areas we just talked about. You've got the memory component, which is where it keeps track of all your variables and functions. And then you have the code component, which is where the code actually gets executed, line by line.
Now, here's where it gets super interesting. This context, it doesn't just pop into existence all at once. The JavaScript engine is actually really methodical. It builds this entire environment in two very distinct phases. First up, we have the memory creation phase. This is where the engine does a quick first pass over your code and just sets aside memory for all the variables and functions it finds. Then, and only then, does it move on to phase 2, the code execution phase, and that's where it actually runs the logic that you wrote.
So let's really look at that first phase. As the engine scans our code, it sees the variables n, square2, and square4. It immediately allocates memory for them, but it puts in this special placeholder value you've probably seen before, undefined. But look at the function, square. For functions, it's different. It actually takes the entire chunk of code and stores it right there in memory. Okay, now for phase 2, the fun part. This is where the code actually starts running. The engine goes back to the top, it sees that first line, var n equals 2, and bam, it takes the value 2 and places it into n, overwriting that undefined placeholder. But notice, square 2 and square 4, still undefined. Why? Well, because we just haven't gotten to those lines of code yet.
Okay, so that's the global context. But things get way more interesting when we don't just declare a function, but we actually call it. Invoking a function opens up a whole new world.
You can think of functions in JavaScript as their own little mini programs. Every single time a function gets called, a brand new, completely separate execution context is created just for that one call. It's totally fresh and totally temporary.
So right when our code calls square of n, poof, a new context is born. And guess what? It goes through its very own two-phase creation process. In its first phase, it scans its own code and allocates memory for its parameter, num, and its internal variable, ans, and it sets both of them to undefined. Then, in the execution phase, the argument we passed in, remember the value of n was 2, gets assigned to the parameter num. Then the next line executes, ans equals num times num. The engine does the math, 2 times 2, and the result, 4, gets stored in ans. And here is the magic moment. The return keyword sends that value of ans, our number 4, all the way back to where the function was originally called. And then, in an instant, its job is done. The entire execution context for that function is completely destroyed. It just vanishes. And that completes the whole cycle. Control goes right back to the global execution context, and that value 4 that we just returned gets assigned to our square2 variable. Then the exact same process kicks off all over again for square 4. A new context gets created, it runs, it returns 16, it gets deleted, and that final value is stored in square 4. Okay, so I know what you might be thinking. With all these contexts being created and destroyed, and what if a function calls another function, which calls another one, how on earth does JavaScript manage all of this without getting completely lost? Right? I mean, it seems like it could get incredibly chaotic really fast. You could have contexts nested inside of other contexts. There's got to be some kind of system to manage the madness. And you'd be right, there is a system.
The secret to all of this is something called the call stack. It's actually a pretty simple idea, but it's an incredibly powerful tool that JavaScript uses to keep track of everything and manage the flow of your entire program. The absolute best way to think about this is like a stack of plates. When your program starts, the global execution context is the first plate you put down on the table. Then, when square n gets called, its new context is like a new plate that you stack right on top. Now here's the rule. JavaScript only ever cares about the plate that's on the very top of the stack. When square n returns, its plate gets taken off the top, and control goes back down to the global context below it. Then square 4 gets pushed on, and then popped off. And finally, when the whole script is done, that last plate, the global one, is removed, and the stack is empty.
Now, you might hear this called a few different things if you look it up online, like execution context stack or runtime stack. Don't let all the fancy names fool you. They all refer to this exact same beautiful mechanism that manages how your program runs.
So, okay, we've gone pretty deep into the theory of how JavaScript works under the hood. But why does any of this actually matter for you when you're just trying to write code every day? It matters because this entire system, the execution context and the call stack, is what determines the exact order your code runs in. Have you ever gotten that maximum call stack size exceeded error? Well, that is literally the call stack telling you that you've stacked way too many plates. Understanding this flow is the absolute key to debugging those kinds of problems and really truly knowing what your program is doing. So I'll just leave you with this question. Now that you can actually visualize the call stack in your head, you can see those contexts being pushed on and popped off, how is that going to change your approach the next time you run into a tricky bug or a weird error, or you're just trying to trace the logic of a really complex application?